Welcome to the Extreme Broadband Engineering Cable 101 training series. In this session, we'll cover insertion loss. The learning objectives for this session are: define insertion loss, understand what insertion loss is, review insertion loss specifications, and how to use splitters and directional couplers as building blocks for other splitting devices. Let's get started. Insertion loss is the attenuation the passive device has to the signal as it passes through it. Here we're showing a signal flowing from the input to the output of a two-way splitter. A two-way splitter has 3.5 dB of insertion loss. Insertion loss is the same if the signal is traveling from the input to the output ports or from the output ports to the input port of the passive device. Here we're showing a two-way splitter with a forward signal flowing from the input to the output ports and the return signal feeding from the output ports to the input. In both directions, the insertion loss is the same. Ideally, the insertion loss should be as low as possible. The lower the dB value, the better. The insertion loss through passive devices is considered a flat loss. What we mean by this is that the insertion loss is the same across all frequencies. But in reality, the loss may vary several tenths of a dB across the frequency bands. Let's take a look at insertion loss specification sheets. Here we're showing a specification sheet for a broadband digital splitter series. This includes the two-way, three-way, three-way balanced, and four-way splitters. On the left side is a column labeled frequency. Here we break the frequencies into 8 different bands, starting with 5 MHz, going up to 1 GHz. Next to that is a column labeled min-max. These are the worst case insertion loss numbers for these devices. These numbers are normally used by the engineers and designers of cable systems. The column next to that is labeled typical. These are the specification numbers that you would typically see for the majority of these devices in the field. Notice that the insertion loss at 5 MHz is 3.5 dB and 3.7 dB at 1 GHz. Over the entire frequency band, it only loses 0.2 of a dB. Most passive devices have minimal loss across the frequency band, and that is why we refer to them as a flat loss device. A two-way splitter is considered a power divider. The splitter's input signal is evenly divided between the splitter's two output ports. If a splitter divides the signal equally, why when we inject a 40 dBmV signal into the input, don't we have 20 dBmV, or half the input signal on both the output ports instead of the 37 dBmV that we're showing here? We have to look at the splitter from a power perspective. If we convert 40 dBmV to wattage or power, it's equal to 0.1333 milliwatts of power. On the output ports, you'll have half of the power. In this case, 0.0668 milliwatts. So from a power point of view, the splitter is actually splitting the signal in half. Once converted back to dBmV, we can easily see that the splitter has 3 dB of insertion loss. In reality, the splitter loses an additional half of dB due to mechanical interfaces and has 3.5 dB of insertion loss. A directional coupler is an uneven power divider. The directional coupler's input signal is unevenly divided between the out and tap ports. Directional couplers have an input port, an out or through port, and a tap or down port. In this example, we're showing a BDC 1106, which is a directional coupler that loses 6 dB on the tap port. Let's look at the signal flow. Here we're feeding the input with 40 dBmV. The signal flows from the input to the output port, which is the insertion loss path for directional couplers. In this case, it has 2.1 dB of insertion loss for an output of 37.9 dBmV. From the input to the tap or down port, a directional coupler loses whatever the value of the directional coupler is. In this case, 6 dB for an output of 34 dBmV. Directional couplers come in many different values. The lower the tap value, the higher the insertion loss from the in to the out ports. Here's a specification sheet for our broadband digital directional couplers. Looking at the 4 value, The insertion loss ranges from 3.7 dB at 5 MHz up to 4 dB at 1 GHz. On the 30 value directional coupler, the insertion loss ranges from 0.6 dB to 1.3 dB. So you can see the lower the value, the higher the insertion loss. The higher the value, the lower the insertion loss. The two-way splitter is one of the basic building blocks of other splitting devices. On the left, we're showing a two-way splitter. On the right, we're showing the symbol equivalent of the two-way splitter, indicating the input, 3.5 dB of loss, and two outputs. Using this symbol, let's build other splitting devices. On the left is an unbalanced three-way splitter with one leg losing 3.5 dB and the other two losing 7 dB. On the right, let's build the symbol equivalent of the three-way unbalanced splitter. Let's first look at the 3.5 dB leg. If the two-way splitter is the building block and it loses 3.5 dB, we know that this leg is fed directly from one leg of a two-way splitter. The other two legs lose 7 dB. So if we add one more two-way splitter to the other output port of the first two-way splitter, we get a 7 dB loss. So a three-way splitter is made up of two two-way splitters. On the left is a four-way splitter with all legs losing 7 dB. On the right, let's build the symbol equivalent of the four-way splitter. With the three-way splitter, we saw that the 7 dB ports were made up of two two-way splitters, one feeding the other. So a four-way splitter is made up of one two-way splitter, and its two output ports, each feeding an additional two-way splitter for 4 ports with 7 dB of loss each. The directional coupler is another of the basic building blocks of other splitting devices. When combined with two-way splitters, they make up all other splitting devices. On the left, we're showing a directional coupler, and on the right is the simple equivalent of a directional coupler, with the input port, tap or down port, an out or through port. Now let's look at a balanced three-way splitter and how it's constructed. On the left is a balanced three-way splitter and each port has 5.5 dB of loss. On the right, let's build the simple equivalent of a three-way balanced splitter. In this case, we're starting with a 5.5 dB directional coupler. The tap leg, which loses 5.5 dB, feeds directly to one of the 5.5 dB ports. The output port of the directional coupler loses 2 dB. So in order to get an additional 3.5 dB of loss, we add one two-way splitter off this leg for a total loss of 5.5 dB on the other two legs. Now each port has 5.5 dB of loss. Let's review what we've learned in this training session on insertion loss. Insertion loss is the attenuation the passive device has to the signal as it passes through it. Insertion loss is the same in the forward and return directions. The lower the insertion loss, the better. A two-way splitter is a power divider. The splitter's input signal power is evenly divided between the splitter's two output ports. A directional coupler is an uneven power divider. The directional coupler's input signal power is unevenly divided between the out and tap ports. Two-way splitters and directional couplers are the building blocks of all other splitting devices. Thank you for viewing this training on insertion loss. For additional training topics, see our website at www.extreme-broadband.com.